The National Science Foundation has selected the Florida International University's Wall of Wind as one of the nation's major experimental facilities under the Natural Hazards Engineering Research Infrastructure, or NHERI program. NSF's investment in NHERI allows researchers to explore and test groundbreaking concepts to protect homes, businesses, and infrastructure lifelines, and to enable innovations to help prevent natural hazards from becoming societal disasters. The Wall of Wind is a shared-use, multi-scale testing facility located at the FIU Engineering Center in Miami, Florida. The EF comprises a secure 72,000 square foot area dedicated to wind research and testing. Conveniently located 8 miles from Miami International Airport, the Wall of Wind is less than a mile from FIU's main campus, where the National Hurricane Center is co-located with the National Weather Service Forecast Office. The main campus is also home to the International Hurricane Research Center and Extreme Events Institute, which oversees the Wall of Wind program. The Wall of Wind, or the WOW, deploys the latest technology in hurricane simulation and damage mitigation research, which is critical for achieving hurricane-resilient and sustainable coastal communities. The WOW's 12-fan system provides controllable, programmable, and repeatable testing in flows that adequately and economically replicate hurricane winds accompanied by wind-driven rain. EF users enter the Wall of Wind through the Operations and Control Center, a 1,300 square foot air-conditioned space that houses the video conferencing and telepresence area, the control room, staff offices, and the sensors storage room. The Operations Center serves as a conference room for up to 30 people on site. Here, 3 large high-definition screens allow on-site users to view wind tests in real time. Telepresence capabilities include remote viewing of tests and near real-time data monitoring and video streaming. This enables off-site users to interact virtually with the EF technical team and provide feedback during the experiments. The control room is adjacent to the viewing and monitoring area. This is where the EF technical team operates the Wall of Wind fans and data acquisition system and monitors tests. The sensors storage room houses most of the smaller instruments used in the facility to monitor wind speeds and wind-induced effects, such as pressures, forces, deflections, strains, and accelerations. The instruments include turbulent flow instrumentation Cobra probes to measure wind field characteristics, the Scanivalve pressure measurement system, which monitors wind-induced pressures, single degree of freedom load cells and multi-axis load cells, which simultaneously measure forces and moments along the 3 principal axes at sampling rates up to 500 Hz, accelerometers and strain gauges to estimate wind-induced vibration and strains. The EF employs 4 National Instrument Compact Rio backplanes to facilitate data acquisition using LabVIEW software. The Wall of Wind building itself is 8,000 square feet and houses the 12-fan system and the 14-foot-high by 20-foot-wide test section. The fan system is composed of a 2x6 array of ducted fans on a wide-focused arc arrangement, which creates a natural contraction for the wind flow. Each fan is powered by 4,100 60-volt electric motors rated at 700 horsepower each, with a combined maximum power rating of 8,400 horsepower for the entire system. Each fan develops a flow rate of 240,000 cubic feet per minute and a total pressure head of 15 inches of water at the maximum rotational speed of 1,800 RPM. 2 variable frequency drives, or VFDs, control the fan speeds. These are located in air-conditioned fiberglass enclosures to maintain an optimal operating environment for the drive electronics. Each VFD controls a bank of 6 fans in the top row and 6 in the bottom row. They allow independent RPM variance in each fan bank if needed. The Programmable Logic Controller, or PLC, manages communication between the human-machine interface, the motor drive units, fan performance monitoring instrumentation, and the multiple fail-safe and human safety devices located throughout the facility. The short contraction section boosts wind speeds generated by the wall of wind up to about 160 miles per hour. Downwind of the contraction section, a 30-foot-long rectangular flow management section provides the required fetch length and contains the spires and floor roughness elements to generate atmospheric boundary layer or ABL wind flows with turbulence. Interchangeable spires and roughness elements enable the simulation of various terrain conditions. Water nozzles mounted on the spires are used to generate wind-driven rain conditions for water intrusion experiments. Different numbers and types of nozzles can be selected to simulate various rainfall intensities and raindrop size distributions. At the exit side of the contraction section is the 16-foot diameter steel turntable. Test models can be placed on the turntable during experiments and rotated through multiple wind directions to simulate various directional wind effects. The turntable may be operated manually or automatically, according to a user-defined rotational profile. The pit below the turntable allows users to place data acquisition monitors directly underneath the turntable, where they are protected from the wind and rain fields. Across the two sides of the testing section are two masts with lighting and surveillance cameras. High-definition cameras mounted on the masts capture live streaming of tests, allowing for remote viewing, monitoring, and slow-motion replaying of test events. Downwind of the WOW building is an open area bordered on the north by a 15-foot-tall debris wall, which prevents debris from destructive tests from escaping the facility's secure area. Adjacent to the Wall of Wind building is the 3,000-square-foot Staging, Construction, and Instrumentation, or SCI building. The SCI building houses a fabrication shop with retractable compressed air and power utilities. Here, test specimens are constructed and instrumented before being moved to the Wall of Wind. Multiple users are able to use various EF resources at the same time. For example, the SCI building can be used by one user to build and instrument models without occupying the WOW building itself, where another EF user can be carrying out testing. The EF includes a 1:15 scale version of the WOW that can be used for small-scale experiments, including preliminary studies for tests that will later be done at larger scale in the full-scale WOW. The small-scale Wall of Wind system also serves as an excellent transportable tool for STEM education and community outreach programs to engage underrepresented groups, K-12 students, and teachers in interactive wind effect lessons. To enable effective use of resources, users will be provided with a suite of services, including planning, safety training, test preparation, test execution, data quality assurance, and data management. For potential EF users preparing NSF proposals, the WOW team will help them with information on facility resources, capabilities, services, and recharge center rates. NSF-funded users will be assisted with training, test planning, scheduling in coordination with the Network Coordination Office, or NCO, and test execution. Users will be provided with training on EF site access, operations and safety policies, personal protection equipment, and emergency policies. EF technical staff will help users with test specimen construction and instrumentation using the SCI building. Users will be helped with the test setup for ABL profile simulations and rain generation as needed. EF staff will assist users with test protocol implementation for aerodynamic wind-driven rain and failure mode testing by performing instrument calibration, data acquisition, data quality assurance checks, and high-definition video imaging. EF software application and specialized data analysis will be performed if needed. Access to telepresence will be provided to off-site users for remote participation, monitoring, and feedback. User data packages will be archived and uploaded to the Nheri Data Repository in compliance with Cyber Infrastructure Awardees' cybersecurity policies. EF staff will facilitate post-test specimen removal, disposal, and cleanup. Users will be provided access to office spaces and business support services. National Science Foundation-supported researchers use the Nheri Wow Ef to gain new insights into wind loading, wind damage, and rain intrusion mechanisms pertaining to a variety of structures, components, and materials. The results of these tests will help significantly improve current design practices for structural systems, building envelope systems, and lifeline infrastructure. Studies that will allow technical breakthroughs for achieving resilient and sustainable buildings and civil infrastructure. Through education programs and community outreach, the Wall of Wind also fosters the growth of a diverse workforce with expertise in basic science, engineering, and wind damage mitigation, crucial for next-generation leaders in these nationally important fields.